Okay, hello Finland and with love from Germany. What I will be presenting today is behavior tree-based test case specification. What a specification means in this context is it means another way of writing our test cases or our keywords in robot framework. So, who am I? What I do? I'm currently consultant at Sogeti Capgemini, and I am also a maintainer and developer some libraries in Robot Framework. So, and I will be presenting today a little fast at the first because of time limitation. So I will be asking your attention and focus today. So what's the key strength of Robot Framework? It's actually its syntax. It's easy of use. Even non-technical people can really read it and understand it, what's happening there. And it has also another strength, which composition of keywords. Keywords can be abstracted into another keywords, and you can make deeper and deeper. And an ironic example of a real-world keyword, which is actually not, it's just joke. Keywords doesn't look like that, and you can use an abstraction to make it beautiful. So the real-world test case example could be like this. In the same level of abstraction in Python and in Robot, as you can already see the difference. A very top one is very readable, and the bottom one, the written in a Python code, it's not that much readable. Like if I'm a programmer or if I'm non-technical person, I would prefer the top one. So before I get to my subject, I would say how I categorize test cases, how I categorize keywords. Simply, I categorize them to two categories, one of them being simple and second, complex. To human mind, it's really easy to understand between the difference between complex and simple. But what does it mean for computer? For computer, it means if I have a lot of possibilities in my test flow or my workflow, then it is complex. If I don't have that much, or I have very limited, let's say 3, then it's simple. So where is the problem? Problem actually is not in the test case itself. It could be occurring in the when you apply the keyword itself, when the keyword gets complexer and you don't abstract it. So does it defeat the purpose of using keyword-driven framework? It's not, because I said, and I like to name the abstraction, like you can take your load and sweep it under the carpets and everything's fine. So in a real world, actually, I wanted to also say you have UI tests and they get to complex, even the simplest one. Like as an example, if you have a tray icon, let's say, and what's a tray is the very bottom right of the windows where your Wi-Fi icon and date and so on is, and you want to open your UI from that area, and you have a tray icon and you want to click on it. You have 3 possibilities. It's either next to the Wi-Fi, or it's grouped in the overflow area, which you can open it clicking on that button. So even such an easy task like to open your application, you have several possibilities to cover in your keyword if you want to provide a keyword. Let's open my app by tray. So if you look back to our test case, if I open, if I just look at very top layer, it's still readable, and I just swept all the load under the carpet. In reality, like if also I also am a test engineer and I wanna give a keyword, I wouldn't writing it this way. In the real world, it was actually this way, like a very top one, as you're seeing here, open, and and as you see it abstracted, and it's right now it's easy to read, but the abstraction level you can't keep going all the time. Like it's you can't just grow your abstraction and decrease your transparency. That's why you just need some level, like some depth. And in this case, in the real world, what we were talking about, it's just this one, And this was the second abstraction, and we didn't abstract it more, and just we stopped here. And it's still readable. It's okay. So what this test case does, actually, as I said, it covers all the possibilities. As you see here, if I already know where the button is, I will not check it under the overflow. Otherwise, I will check it next to the Wi-Fi. I will open the overflow. If it's not under the overflow either, I will fail. That's simple. So can't we grow and do more abstraction? Of course you can. But we didn't. So where is the problem? You don't come, you are not trying to solve some problem. So till this moment, as I say, I'm not trying to show you some problem. I'm just trying to say even simplest tasks in your UI automation can also be complex. I will be skipping that one because of time limitation, which shows other cases of UI element getting complex. So I was showing today another way of thinking, another way of programming, and which is behavior tree-driven programming instead of keyword-driven programming. So why should I show an alternative? Because, as you know, scripting is not always engineering, it's sometimes art. So you could have different ways also. So actually, as you've seen in the previous version, it's the very same keyword, it does very same thing, and it's a very same abstraction level, but it looks different. So in reality, actually, right now, if you look at it, it has no coloring. So just to be fair, I will be stick with coloring, which I did manually in the presentation. So as you see, the very right level for now in this slide, it does very same thing, but in another syntax. Explaining what it does, I will be doing in the next slides, not for now, but I wanted just to show how they compare to each other, the both syntaxes. So left one is a very traditional way, and the right one is the new way, the behavior tree way. So it looks different. So if you want to try it right now, it's a proof of concept. It's not a library. It's not a functional one. I wouldn't suggest you to use it in a production. So you could use under this link, the library. You just import it in your robot test case and start using it. If you have no time to write or convert to your own test cases, there are examples here. One being real world test case and 2, 3 demo test cases also, which you can use. Next one. So what is a behavior tree? Behavior tree is hierarchical model for controlling task execution decision-making structure, which means it's a tree in computer science. It has nodes and edges. Nodes are many types in this case, and edges just connect them. And to explain about it, I would explain on a example instead. So as you see here, you have a decorator at the very top, which says repeat every day. I think it's understandable. What the control flows does actually, which are here, in our case, the blue ones, selector and sequence, they control my workflow, and I have conditions, which just deliver true or false all the time, and I have the actions, the yellow ones. So in the literature, you may also find the selector and sequence in another form, which is question mark for selector and arrow for the sequence. So you know the difference. And selector also known as fallback. But in our cases, I will be calling them with another name, sorry. I will be calling selector one should pass and sequence all should pass. And I will be explaining why, how the thing works. So in this case, in the very example, what it does, actually, it's ask himself, do I have or do you have an exam today? If yes, I will study. Otherwise, I will fail. I will play game. So let's explain how the selector and sequence work. If we start very bottom, very top left, so let's say we have a selector. How it works, it just executes from very left children ordered to the right. And if it executes and looks for the result, if it fails, in this case, it fails. It is, as I said, all should pass. It should pass the first one, second one, and third one as here, so it can go further. Otherwise, it will fail. It could also be seen as an AND gate. If you know, if you don't know, it's not important. So let's concentrate on the selector one. Selector one could be also seen as a OR gate, like it executes the first one. If it fails, it keeps executing the second. It keeps executing the third and fourth, and until seen at least one, so it can succeed. So I called him one should pass, and I called this guy all should pass. So if we go to our example, what I said, as we said, the curator, I will be executing this one every day. One should pass. I will be executing this one, sequence. All should pass. And I will be executing, do you have exam? It says no. And sequence, okay, all should pass. Then I didn't pass. I say the selector, I didn't pass. Selector goes to the second one. I play game. Yoo-hoo. So, but another day, I'll be asking the same question. I will be going the same workflow, and it will say yes, because I'm all should pass. I will go to study. So, but how I integrated it into the robot? Simply because everything in robot keyword, just I took every possible node and made a keyword in the robot. That's it. And if you want to see in a visual representation, because a tree could be represented visually, you could see complex trees will look, complex test cases will look like this one. And every selector keyword are actually keyword, but you can just use your own robot keyword as actions or even conditions. Simple test case will look like this or this, it's the same thing. So, to summarize the paper I've released 2-3 years ago, I just proved that the behavior tree is applicable in test automation, which is the first point. And if you have a simple test case or simple keyword, it doesn't improve nothing. So don't bother yourself using it. It improves only if you have a complex test cases. It improves the readability and transparency and understandability. So is that all? Like it just makes my keywords more compact. Is that all what it improves? It improves the readability and understandability. What about functionality? Actually, it improves also the functionality. So gamification, I've heard once that explaining things with games is easier to comprehend. So instead of showing boring examples of changing settings, I will be making a game. In our game, maybe it's, the game under the 4 in line or 4 winds. In our example, you need to have at least 1 crows or 1 X to make the table or to check the table as valid. Otherwise, every other case is table invalid. That's how you solve this puzzle in our example. And you have already all the keywords. So how you would write a keyword test case for this test? It actually will look like the right one is the traditional style, the left one is the behavior tree style. Because we don't have time, I can't explain and go through the keyword. It is how it look like. In those both cases, the problem is that our goal is not to solve the puzzle. Our goal is test the app. Because the app could have one of the results and I'm not checking if all results are coming or the app is delivering all the results. I'm just solving the puzzle and that's it, and I'm naming a test case. Actually, it's not a test case. It just, you have written robot which solves the puzzle. So how can I solve it better? Like in traditional robot, it's kind of very, very hard. Like you should go to Python and implement other functionalities to do it. In behavior tree, it's easier to say. I had already implemented at very top repeat until all lines pass. For another case, I'm thought it could help me. Actually, it kind of helped me, and it could check if the first and the second and repeat all the time. I'll take the both at least, and a random case of the third one, sorry. So what are the all cases I will be also showing here? All the cases are these which is 16, and you could actually use the currently available decorators in the behavior tree and cover all those three, only the 3 but not the 16. Actually, it also be very easy job for you need to write another decorator, which means repeat until all the given possibilities are passed or occurred in this case, and you give all the possibilities here. It says 1 and 1 in the real world, so because start application and close application should always pass, and that's it. You will be covering all the possibilities without overhead, without Python calls and something else. So that's about functionality. And I will be showing also the logs, how it looks like in the end. Currently, it's a proof of concept. You don't accept much of it. It also shows, so to say, all the tree in a text form. And it says a tick, a green if it executed and passed. It says dash or minus if it's not executed at all. And I will be showing also a failed form. So, and it says X, it failed. So also you see here button, what is that? Actually, it's a memory state. Like I have a because I'm hierarchical architecture, I could know every step, every state, so to say, if it failed or not, or returned none. It's not executed as yet, and I could be working on them. It's my memory, and that's how the repeat until all line passed works, relying on those statistics. And what we must have, so we can call this product as a product, not a proof of concept, at least some coloring, because right now looks like a mess, and there's no coloring at all. And as you see, we may also improve the syntax, but I can't do it because I'm just using keyword as a keywords, and keywords cannot take variables as arguments, which that's why you should give the backspace thingy, and you should give those, like some improvements in syntax is necessary to be used in a production at least. And what we could have, the vision is to having not just the syntax form, but having the visual representation of tree, which eases the reading. And you could also having a drag and drop, maybe programming style if you have all the keywords. So you don't need, because as you've seen, you don't need to write any if else, you don't need to write any for loop, because all those are given in the box forms. You just drag and drop those. And it could also good to have some visual debugger, some visual logging outputs, a ticker. A ticker is very useful thing in behavior tree, which I haven't simulated it in my proof of concept, and parallel nodes, which I haven't used it, and it was enough without the parallel nodes to cover all the real world test cases and convert them to behavior trees. But the ticker is really needed for robotics. If you are executing something, have a lot of sensors, there's a lot of real-time activities, a ticker will be very, very useful. So, and I think the last slide is coming, if it functions, yeah. So where I could be used, it could be used in game testing. Actually, in game development right now in Unity is already used, in robotics is already used, and autonomous driving is already used. And it could be used for testing those. Also, because otherwise, if you try to script them, it will be like a mess and thousands of lines. In a visual form, is more compact. It's more readable. And right now, the AI agents are really getting fancy, and you could also this technology or this approach could also be used to test those technologies. So thank you. Actually, what I have shown is just the same test but shorter. Thank you.
Thank you, Nubar. Questions?
Question.
Okay, please. Oh, sorry. Oof.
Thank you, Nubar, for the great talk. Just a question: can you combine the behavior tree with Gherkin?
Gherkin, actually, if you can combine everything, I think, like because in a IT world, in information technologies, if you look at from scientific point, behavior trees include the state machines, which is a state machine. Actually, every programming language, general programming language today, like it is included. That means everything they can do, behavior tree also can, mathematically.
Actually, it's interesting that you say that, because I was thinking the same thing. I was like, not really with the Gherkin part of integrating it with the test, but I was kind of curious with your display, and you were talking about the colorization of it and displaying, which was really, really fascinating because it was so clear to see that up there. But I was wondering if some of the things that Daniel had done with the Gherkin in terms of being able to see a script in one language, as you were showing kind of the two, see one script in this way, but I want to write it a different way, make it much more visible. So that's an idea of how we're doing that in almost an imaginary, I would not say imaginary, but more in a theoretical sense, whether that same idea can be applied to your work, because that's really fascinating.
Okay, thank you.
So Ed, was your idea kind of like having different view modes? Ed, was your idea kind of having different view modes for the test case, so you could see it visually, or you could?
It's a different language, essentially.
Yeah.
I mean, it's a visual language, so your natural language, but it was just basically, I could write my natural language in very cursive writing as this, or I can summarize it in almost a very structured way, which is what I saw, a very structured way. And so it's just the idea of a tool that can look at how it structures a language almost in a very visual sense and say, this looks totally different than this, but my tool can interpret it this way. So that's kind of where it's going.
So there was a question there. Yeah.
In your experience, does the nice-looking behavioral tree execution take longer?
Actually, it was also proven that's doesn't. It's the same.
Right.
I've tested it on several cases, and it doesn't different. Maybe if your script is really, really big, and maybe back then because you're just adding some memory on it, maybe. But in my cases, at least it didn't differ.
Yeah, I was basing it on if you use run keyword and return status, it's executed immediately or just waits for the timeout of the next keyword. But if you have one should pass, then it tries, and another.
Yeah, but if you're repeating it, but in your traditional way, if you compare the repeating one with the traditional one, you should also repeat the traditional one. Then you can compare. You can't say because it's repeating, it's longer. It's obviously if you're repeating, it will be longer.
There as well. All right, thanks. Thank you very much.
More questions? Then I would like to ask from Pekka. Pekka, what are your feelings about this syntax? Can you give Pekka a mic?
So,
this was the question that you were afraid.
Maybe we should go back to the slide. Maybe.
No, actually, I was about to not ask a question, but as a syntax proposal, I have nothing against the syntax. I think it's fine, but one thing that could possibly help with your like how to get those actual keywords at a low level, how to get them highlighted, probably that you could possibly, instead of using the syntax that you now used, you could try using the new group syntax so that the groups would have specific names, and then you would have a listener that sees those names and handles them somehow. So that might allow you to have
as I developed it, I think...
The group syntax is new in 7.2 that was released a month ago.
Yeah,
so
as I did the research, it was maybe the 4 or something. Like even this one, in my paper, you will be seeing the older one. In here in slides, I've just improved the traditional way also. If you compare it in my first initial paper, you will see like it is very different between the sizes of the both syntaxes, but right now like the robot got smaller, compactor with the newer version. So,
yeah, I mean that's just an idea that something you may want to try, because if you want to get, for example, IntelliSense to those so to get it highlighted, so if that would allow you to use just normal robot framework syntax with those groups and listeners and so on, that might be possible, but something to try.
Thank you.
More questions? Anyone? Okay. Thank you, Nubar. Here's your jersey. Excellent talk.